tonight because we lost one of our hosts. Unfortunately, he's come down to the dreaded lurgy. So it's just Terry and myself and our remarkable backroom team who are kind of holding it all together. This is our monthly show. With our friends at Space Store Live. And we've got a lot to talk about this month. We could have covered a ton of stuff this month. We have so many options, like black holes, age of the universe, all sorts. We're going to be covering a little bit of that anyway. But yeah, just this is me, Nick Howes. This is Terry. I'll just point in the right direction. Terry Moseley, who is one of Ireland's most notable astronomers and has just got back, I believe, from the Cosmos Star Show.
Yes, indeed. At least you didn't say infamous, which would probably been more appropriate. Yes, we had a very good, the first one after COVID in a new venue, which was rather strange, but went very well. And yeah, great to see everybody again.
Yeah, Cosmos. It's if you ever get a chance to go over to Ireland, Cosmos. I was very privileged to speak there a few years ago. Terry and I probably, I think, first met in person. And he ended up buying some Apollo memorabilia from me. I seem to remember at the time. I was just handily carrying with me. Funnily enough, Terry, I'm going to be in Belfast on Saturday this week. I'm going to be only for a few hours, about 4 or 5 hours at the airport, because I'm flying to Kielder in Northumberland and then flying back via Belfast. So I've got a bit of a layover. Yeah, it is. It's just the flights are all over the place. But yeah, so I'm going to be in
unfortunately, I'll be in Dublin, so I'll miss you. But yeah.
But yeah, if you ever get a chance to visit Terry and the team over in Belfast, and some of the remarkable stuff that's done over in Ireland, totally recommend it. Anyway, on with the show. We got people in the chat room already. So good evening to Robert and others that are in the chat room and watching us. Thank you very much for joining in. It's always a pleasure to host this show. And we know how many people we get listening to us live and how many people listen to us on various catch-up methods, YouTube, etc. So it's great, and we are really, really chuffed to always kind of do this in a slightly irreverent way, slightly silly way. Anyway, moving on. Let's go on to our first slide, and just prompting our backroom team there. If they can move on to our first slide, that would be fantastic. If not, I can just rattle on about it. Well, welcome back. Here we go. Cool. Yeah, slightly different format, as I said, this month, but we're going to crack through. Anyway, Virgin Orbit. This is big news. This was the big news, pretty much for the UK. In terms of the space sector. So I'm currently involved in a big study for UK government and various things on the UK space sector and various things associated with that. So this news hit everyone, I think, like a bit of a ton of bricks. So after the January failed launch of Virgin Orbit out of Spaceport Cornwall in Newquay, where the Cosmic Girl that you can see in the picture there failed to launch Launcher 1 into orbit. So it was, great separation. The insert to orbit seemed to go pretty well, and then there was a catastrophic failure. They lost 9 satellites into the North Atlantic, just off the coast of Tenerife. Now, this has had a knock-on effect that's been really quite catastrophic in terms of Virgin Orbit's overall solvency, as were. And as it says there, they have now filed for insolvency, which basically means that they're teetering on the edge of bankruptcy. To put this into context, when Virgin Orbit first floated on the stock exchange as VORB, their share price was in excess of $10 a share. The last I looked, which was about 30 minutes ago, it was trading at 42 cents a share. So their capital has pretty much gone. There was talk over the last weekend of discussions with various venture capital organizations, and one person in particular, Matthew Brown, is a Texas-based venture capitalist, was supposed to be in quite deep negotiations with Virgin Orbit's team, Dan Hart, and the various other people at VO. Now, Virgin Orbit have had to furlough, unpaid, all of their staff. Pretty much. It's like across the globe, it's nearly 750 staff, obviously predominantly in the United States, but they do have staff based out of Spaceport and Cornwall as well. So Matthew Brown, this Texas-based venture capitalist, was rumored to be talking about investing, I think it was around about $200 million to kind of recapitalize and refloat Virgin Orbit. Now, why is this important? Well, from the US space perspective, it's not so important because you've got dominant players like SpaceX, you've got United Launch Alliance, Lockheed Martin, etc. involved. Obviously, you've got NASA. In the Southern Hemisphere, you've got Rocket Labs, Peter Beck out of New Zealand, doing a phenomenal job in terms of, launching lots and lots of satellites. You've got JAXA in Japan. You've got ISRO, the Indian Space Agency, launching the PSLVs. You've got the Chinese Space Agency. So this only really impacts predominantly the UK in terms of launch, because it doesn't impact the European Space Agency, because European Space Agency weren't planning on using this as a primary launch vehicle. They've got obviously a key launch site out of Kourou. They've got the Ariane series and various Vega rockets, etc. But this really does impact the UK, because the UK was aiming to become a space launch provider, as it were. Now, UK does an awful lot in terms of instrumentation, in terms of research and development, in terms of design and build of satellites. There's an awful lot of work goes on here. So the UK does have quite a booming space sector. There's around about 47,000 people, depending on whose figures you believe. And there's a state of the UK space industry report only published today. Now, the UK government's intention was to capture around about 10% of the global launch market. Now, I always thought that was a bit of a lofty goal anyway, because key to that is being able to launch lots of satellites, high cadence. Now, the problem we've got with the UK is the satellite launches, the only equatorial launch option, and don't forget, a lot of the satellites that are used for things like Starlink, etc., all come into equatorial orbits, and then they kind of move about and they kind of go around the planet as was. The only equatorial launch option for the UK was Virgin Orbit out of Newquay, because essentially the aircraft could take off, could fly south over, more equatorial, closer to the equator climbs, drop the rocket, launch the rocket, and it gets its boost, goes into a really nice nominal equatorial orbit. Everyone's happy. Relatively small satellites, don't forget, because you look at the size of the booster, we're not launching big satellites from the UK. The satellites that were lost were about the size of a small fridge on average, some of them smaller, some of them CubeSat size. The other launch options from the UK are all based up in Scotland. Now, there you're looking at quite high latitudes, which means that there isn't an option in practice to launch into these equatorial orbits. The fuel consumption, etc., and the idea of launching into an equatorial orbit from there is not really one that anyone's flying with. So the orbits that you would be launching into from Scotland would be polar and sun synchronous orbits. Now, they're very important for things like spy satellites, which kind of constantly orbit the Earth over the poles, as it were. And as the Earth rotates underneath, basically they can then image whatever they like on the ground. So if they're over, for example, hostile countries like North Korea, you can be imaging over North Korea. And if you've got enough of these satellites, you can keep this cadence going quite well. Same with Earth observation satellites, doing climate monitoring, etc. So there is a need to launch from Scotland, but there's still all sorts of discussions and what's happening with Scotland and various players involved. And currently there's anywhere between 4 and 6, depending on, again, who you follow, but nominally 4 to 5 launch sites just in Scotland. Now, given that the climate, and this is nothing against Scotland, Scotland's got, some of the most beautiful country, in the United Kingdom, but the weather up in Scotland is not exactly known to be favourable. So the launch window, as it were, for launches from Scotland is quite narrow in terms of, possibly over the summer months. So this idea of taking 10% of the entire launch capability from the world, from the UK, always seemed a little bit far-fetched to me. Now, given the Virgin Orbit situation right now, and as I said, they were hoping to come out of this kind of temporary pause, as they called it, around about March the 21st, but that hasn't happened. And it's looking all the more precarious until potentially somebody does come in and buy them out. Now, that could happen. It's happened today with a clothing manufacturer, Cath Kidston, where the Next Group, another clothing company, have basically taken them out of insolvency. So it can happen, but it's got to obviously make commercial sense to whoever is putting the money in here. And Virgin Orbit's failures, which, they failed twice. They have had some success, don't get me wrong, they have managed to launch to orbit. It's not looking great for them. I don't know what your thoughts are on this, Terry, but to me, it's this end-to-end chain of UK being a launch provider and launch superpower, I think, isn't going to happen. And the size of the industry that they're talking about, they keep saying, it's going to be 10% of however many billion. But a lot of that is down to satellite TV, people like Sky TV, and their market share is collapsing as well because everyone's moving to cable or, Wi-Fi or fiber optic links for their satellite and their television delivery rather than through a satellite dish. So that whole market share that, I keep hearing these huge, ridiculous numbers. And Jonathan Amos from the BBC was talking about this even today. I just think is unrealistic. Terry, what do you think?
Absolutely. I agree totally on all those points. I've been saying for ages that Northern Scotland, much though, like yourself, I like Scotland. With the weather there, it's not really an ideal launch site. And as you say, it's only suitable for polar high inclination orbits. The only thing that surprised me slightly about this Virgin insolvency is that their first launches, which were done from America, were successful. I think they've had 3 or maybe even 4 successful ones. So unless they had a huge loss with this particular failure, and normally those things are covered by insurance, I'm not sure why this one setback has put them in such a precarious position. Now, I'm not an economist or a businessman even, but I would have thought they would have been prepared for the loss of at least one launch, in their first 10 launches, say. And I mean, when we look at some of the other companies that have been launching, their first launches were all failures.
Yeah,
So,
absolutely.
maybe you know more about the American side of it than I do. Are they completely separate operations? I thought it was all part of VORB.
It is all part of VORB, and if you look at their market share value over the last 5 years, it's been generally on a decline for the last 3 years in particular. So clearly they're burning more money in terms of staff salaries, research and development, integration, testing costs, all sorts of things than they were bringing in. And this is obviously the big problem. They needed to have this launch success and this high volume of launch success to really make the business viable. And don't forget, they're also up now competing against SpaceX, who are plunging the price of launch into orbit. And as we've said many times, as soon as Starship goes live, which is looking potentially imminent, it could be within the next few months that they do their first orbital test of Starship. And there's no doubt, as you said, Terry, SpaceX had a huge number of failures in the early days, but they kept going because, there was a lot of investment from the US government. They needed a launch provider for the United States to be able to, remove Roscosmos, for example, and remove the Russian element from having to launch astronauts up to the ISS and, various other space missions. And United Launch Alliance were the dominant player. But then when SpaceX proved their launch reland technology, and massively dropped the price because obviously the reusability significantly drops the price, then it gave the US government and the US sector a real kind of line share of what's happening globally. Indian Space Agency can still compete predominantly because the Indian salaries are quite low compared to Western salaries. And the Indian Space Agency, they can chuck up, one of the PSLV launches was over 100 satellites in one go. So just looking at some of the comments in the chat, fastest way to become a millionaire in the space launch business is start off as a billionaire. Very good comment from Chris there. He's doing it with Twitter as well. And this is the other worrying thing now about, the reliance on SpaceX to some degree is really quite terrifying, in that you only have to look at what's happening with Twitter with the, what Elon Musk is doing with the blue tick issue, and how tens of thousands of advertisers and people are just leaving Twitter en masse. Now, the interesting thing is what to leave it to, because there really isn't a competitor. Mastodon has proven to be a bit of a damp squib, in terms of capability. With Virgin Orbit, with the UK, it was always an interesting one in that, as you said, Terry, they were really successful from the US side, and it would have been cheaper in many instances for the UK launch providers to grab a Peli case, fly their small satellites over to the US and launch them from the US. Because the other issue that Virgin Orbit and the other spaceport operators in the UK are currently facing is the ridiculous level of regulatory oversight that's happening here. So you've got 18 different regulators involved, from the Civil Aviation Authority, Maritime and Coast Guard Agency, Nuclear Agency, all sorts of different regulators who are imposing very, very high levels of regulatory oversight to this, to the point where SpaceForge, one of the people who lost the satellite on the first launch, said it was not economically viable to launch from the UK. And they said it was a complete farce to even think about launching from the UK. So that model's got to change. And the UK government and the regulatory authorities have got to look at this and think, how can we make this actually viable for the UK? And as I said, with Scotland as well, the whole geopolitical situation with Scotland right now is still up on a knife edge, as it were, because the election now of Hamza Yousaf, who is a big proponent of devolution for Scotland and probably one of the preferred candidates from the Scottish National Party's perspective. And we're going into politics here, but this is really important for UK launch. Scotland could still devolve. there was talk at one point when Nicola Sturgeon had kind of quit from the SNP, which are the big party, who are leading party in Scotland, that their hopes of devolution may fade away. I don't think that's now the case. I think there could still be a chance, given the new leadership, that they will devolve. And if that happens, then the UK doesn't have a launch provider, because the UK, Scotland, will not be part of the United Kingdom. So it's really quite interesting. Again, going back to the chat, yeah, technically separate businesses. Cornwall failure, right? Yeah, this is a really interesting thing here. So Virgin Orbit were looking at, obviously, launches of the Virgin Orbit rocket, the Launcher 1, etc., and that was all satellite payloads. How this plays into potentially longer term goals for doing, tourist flights, astronaut flights from Cornwall is a whole different ballgame as well. What we do know is that Spaceport Cornwall are a separate entity to Virgin Orbit. So Spaceport Cornwall are currently in discussion with other launch providers. Now, the question is, who are these other launch providers? It's very easy to narrow this down because you can't do vertical launch out of Cornwall. There isn't a vertical launch site. So it is, again, a horizontal launch capability. The only other organisation who've got this similar kind of launch capability in anywhere near a close to ready form is Sierra Nevada Corp. So that was people like Buzz Aldrin, etc. involved. This is like a mini space shuttle. If you remember the $60 million man in the 1970s, those kind of flying V test aircraft, it's very similar to that. Not really proven technology at this time, but that is the only one that could really launch, because you look at reaction engines and Skylon, great technology as it may be, and launch to orbit from a ground-based, horizontal takeoff is a remarkable thing if it ever happens. But unfortunately, they need a massive runway, and there isn't a runway in the United Kingdom big enough to host that. There literally is not a runway big enough in the UK. So Skylon's not going to be launching out in UK. So it does leave SNC, Sierra Nevada Corp, who do have a UK office, as being probably the only option now for Spaceport Cornwall as a launch provider. So it is interesting. It's not just this. This, I think, put the icing on the cake or the nail in the coffin, depending on what analogy you want to use, in terms of it really screwed the pooch, as the Americans might say, with respect to Virgin Orbit. But it's been a slow decline. Like I said, you only have to look at their share price over the last 3 to 5 years. It has had some peaks and troughs. It had a nice big peak when the whole notion of launching out of Cornwall came about, as it were. You saw a really fine little spike in that, and then it's just gone down and down. As I said, it was collapsing. The report I read yesterday said it was 54 pence a share. As of today, it's 42 cents, a share. So from over $10 down to 42 cents. As has been said in the chat, the quickest way to become a millionaire in the space industry is to start off as a billionaire. It's going to be interesting to see what Jeff Bezos does as well, because, from the US launch provision capability, he's the only competition right now. And as I've said many times, right now, SpaceX have got the US government over a barrel because they're involved heavily in the lunar program. They're providing, the lander for the lunar program. They are the only route to orbit for the astronauts in terms of a US-based launch provider, and they're the cheapest route for everybody else. So messing around with Space Karen, as he's currently being known on Twitter, and no offense to anyone called Karen in the audience, but he's prone to his tantrums, is Mr. Musk. So it's going to be interesting to watch. Anyway,
yeah, there's one other angle, just this major implications for Branson, because Branson Holdings is 75% owner of VR. So if it goes under, that's a big hit for him personally. And as you're alluding to there, that could also seriously affect Virgin Galactic. So
Virgin Galactic,
major story.
They've got all sorts of other problems as well, because don't forget, they were supposed to go live in terms of launching, potentially paying passengers into orbit almost a decade ago.
Yeah.
And they've had lots of issues. They had a fatality with the co-pilot on one of the test missions. So they've still got a big uphill struggle to go anyway, aside from what's happening here. And as you said, it's not easy. This is the thing. Everybody looked at Elon Musk and thought, that's where the money is. They looked at Jeff Bezos, the two richest people on the planet, and they thought, that's where the money is. And it's this Klondike mentality. It's this gold rush mentality. It's like, well, they're rich, so I'm going to get rich because I'm going to do the same thing. I've got loads of money. I can invest in this. It's not how it works. Space is damned hard. As everybody over the years, from Roscosmos, from NASA, from everybody has found out. So, yeah, interesting times ahead. Anyway, moving on to our next story, which takes us all the way to the other side of the galaxy, of the universe, in fact, not the galaxy. This is amazing.
Yep, I was just going to use that very line. It is indeed. This is one of these new discoveries, or not entirely a discovery, but something that's down mainly to the James Webb Space Telescope, beloved of us all. This is an object called CEERS, CEERS -93316. Exciting name, but the amazing thing about it is a galaxy that really shouldn't be there. Now, just to set the context, CEERS is Cosmic Evolution Early Release Science Survey. Bit of a mouthful. And that's basically some of the stuff that is being released at an early stage from the results from James Webb. But we need to go back actually to the predecessor, although it's still there, it hasn't gone away, the Hubble Space Telescope, and it surveyed various areas of the sky. But what it did in this particular case, it surveyed what's called the EGS, the Extended Growth Strip for High Redshift Galaxies. And that was then a target area for the James Webb, with its much more powerful penetrating ability to look way, way back in time into the very distant and early stage of the universe, because it can look into the infrared. So it is serving this area that had previously been surveyed by the Hubble Space Telescope, and it has spotted this galaxy, which I'm just going to call 93316 from now on. The amazing thing about this is it's going back in time 13.7 billion years. And the latest estimate, that this is a galaxy, and it's a big galaxy. It's hard to say how well formed it is, but it's a big galaxy, and it is there. We're seeing it as it was only 236 million years after the Big Bang. 236 million years is a big interval of time for most people, but in terms of the age of the universe, which is about 13.8 billion years, that's just a blink of an eye almost after the Big Bang. And it's a major problem for cosmology and astrophysicists to try and explain how a galaxy can form to that size and that degree of evolution so quickly after the Big Bang. Now, a few qualifications. Excuse me, that redshift is only what they call photometric. It's just looking basically at the color of the light and estimating how far away the galaxy is by the color of the light, how far it has been shifted into the red end of the spectrum. Now, it was originally estimated actually to have a redshift about 16.7, which would have been more or less impossible, basically. But they have now refined that, and they refined it down to 16.4, which is still, as I say, an amazingly early stage in the evolution of the universe. Just in case anybody's not familiar with redshift, because the universe is expanding and everything is expanding away from everything else, as the galaxies move apart, at incredibly high speeds, their light gets shifted from the normal wavelength, the sort of wavelength that you would get if you did a stellar spectrum in the laboratory. It's shifted towards the red end of the spectrum. And the further away the galaxy is, the faster it's receding from us, and therefore the higher the redshift. So it is a major problem. What we need now, and the JWST will follow this up and get a detailed spectrum of the galaxy, and that will then confirm the distance as far as we can tell from the redshift. That is still in progress. I'm not sure exactly if they've done any imaging of it yet or not, but that's certainly to be done. If so, the cosmologists will have an awful lot of thinking to do and to try and explain how so soon after the Big Bang, not long after what's called the Dark Ages, whenever the universe was opaque to light and there were no, basically everything was just a sort of a very, very hot expanding plasma, how matter cooled down enough, condensed enough to form stars and to form galaxies, which then of course heat up as the stars form. But initially stars form out of relatively cold matter. So the big problem is, how did a galaxy as almost as big as our Milky Way galaxy form so quickly after the Big Bang? And I know we've talked about this before, Nick, and you're as puzzled as I am.
It is, because it basically comes down to one of three things. I mean, either galaxies don't form in the way that we think, And that, again, is a fundamental shift. And this is the thing about these giant leaps, as it were, in terms of technology. The James Webb is a massive leap in technology over and above the Hubble Space Telescope. And we talk about spectroscopy from the Hubble Space Telescope. Don't forget, the Hubble only goes into the near infrared, whereas the James Webb is obviously doing mid-infrared and further, and has vastly more sophisticated instruments. The MIRI instrument and the NIRCam instruments are astonishing in their own right. So it will be heavily reliant on the spectroscopy. There are other candidate galaxies that have proven to be far closer after detailed spectroscopy. But if this one hangs up, then, as I said, we've got one of three options: that galaxies don't form in the way that we think, or that the objects are closer than we thought and there's errors in the data. But as I said, needing spectroscopy. The other one is that Fred Hoyle was right. And this is the thing: Fred Hoyle was parodied for years. The poor guy, he was an angry chap, let's put it that way. I met Fred Hoyle many, many years ago. He came to my university and gave a lecture. It's phenomenal. I mean, I've always had massive amount of respect for Fred Hoyle with the steady state theory, because essentially, whilst mathematics and observational astronomy does all point to the Big Bang, there's an increasing number of scientists who are getting really, really itchy about this as to what's going on here. Now, if you look at how this has been achieved, the James Webb Space Telescope, the astronomers involved have been looking at the way that hydrogen gas acts in a way that it actually hides galaxies, the structure of the hydrogen atoms in, the intervening space between here and the galaxy. If you look at the galaxy, if you look in different wavelengths, frequency wavelengths, basically galaxies almost disappear and pop in and out. And this is, it's a weird thing. It's known as a Lyman break. Now, what they've also done is they've looked at another element called the Balmer break, which is at different wavelengths again, and you look at the two signatures, this Lyman break and this Balmer break, and you can help identify where the galaxies kind of sit in space, as it were. And apparently what they found was, in the initial data from the James Webb, there's potentially up to 40,000 anomalous galaxies, of which they've honed down to about 6. And as you said, Terry, this one, forming in 200 to 300 million years after the Big Bang, it's impossible. It can't have happened unless we have got the fundamentals of galaxy formation and the whole concept of the universe's formation wrong. It's the only explanation for this. If it is where it is, where they think it is, and the spectroscopy proves it is where it is, then either the Hubble constant's wrong, the Hubble, time dilation, everything is wrong. Everything is completely wrong, because you can't break the laws of physics. They say, during the first however many nanoseconds after the Big Bang, that superstrings and chaos, and pick a theory. There's been so many over the years that the laws of physics were potentially broken. I'm not a buyer of that either. I think that we've got laws of physics that are, pretty proven to be hopefully universal, as it were, and something is fundamentally wrong with our observations. And it's not a great, we don't have to kind of hang our heads in shame for, hundreds of, thousands of years. We believe that the Earth was the center of the universe. We believe that the sun went around us up until the 1600s. And then Galileo and Kepler and various other people came along and said, oh, that's actually quite wrong. You look at gravitational theory, we had Newtonian gravity, and then Einstein comes along and kind of throws everything on its head. And Einstein's predictions for dark energy, dark matter are now kind of being tested as well. It's not to say that it's a bad thing to get things wrong. That's what science is. That's what science is there to prove, is to observe, look at the data, and then see where the data fits. And if the data fits, great. And if the data doesn't fit, you have to rethink your models. And it's that simple.
I forget who it was, but they said basically the most important observation to make in science is not, well, that's good. It's, that's odd.
Yeah.
You find an anomaly, and that's what gives you your next step forward into solving problems. The other thing that this ties in with, which is one of the things that fascinates me most, which is what they call the Hubble tension.
Yeah.
The difference between the Hubble constant, the rate at which the universe is expanding, given either by the Kobe and Planck data, which is amazingly good when you look at it, in the actual plot of the graph, and what you get by the cosmic distance scale going out to the distant Type 1a supernovae. And as we've said before on a program not so long ago, the measurements, according to each different form of measurement, are getting more and more accurate, and the error bars are getting further and further apart.
Yeah.
There is a big problem there, and this could well be tied in with that.
Absolutely, and going back to making errors, there was a whole debate a few years ago about debris and collision avoidance, and two notable experts in this field, massive arguments saying it's not going to happen. Now they believe it is going to happen, and you're looking at the data. The collision with the Earth and an asteroid or a comet, everybody says statistics point to it's almost impossible. don't bet on it.
Tell that to the dinosaurs.
Tell that to dinosaurs roaming around in the Cretaceous period, because don't look up, as it were. Anyway, moving on, which brings us neatly onto our next story. Next slide, please. And that is, oh no, we're doing printed records next. This is you, Terry. Okay, sorry, I thought we were going to do Diddy Moon, but no, we'll do that in a bit.
No, this is you, surely.
This is, well, okay, I don't mind. So printed rockets.
Yeah.
I can do this as well. So printed rockets, 3D printing. If you're used to 3D printing technology, it's kind of, it's now becoming almost domesticated, as it were, much like standard printer technology. And, I visited a company up in Scotland, going back to the Scottish launch a few years ago, called Skyrora, and they were working on 3D printing a rocket. Now, this is becoming more and more of a thing, in that, the ability to exactly replicate all of the separate components in a rocket on launch is really, really important. So various companies have been working on this. I've forgotten the name of the company because I genuinely thought I wasn't doing this story. But
Relativity Space.
Relativity Space. Thank you, Terry. Yep. Relativity Space were targeting a launch of a completely, pretty much 95% to 96% 3D printed version of a full-scale rocket. So this is the combustion chamber, the propellant injectors, everything in 3D print. Obviously not using plastics, which you'd normally find with your domestic home 3D printer. Unfortunately, it failed. It kind of broke up on launch. Now, whether or not that was due to structural imperfections in the 3D printing, there's all sorts of analysis that can be done post-flight on that. I would suspect that any future launches involving similar technology, possibly the level of inspection on the models, using CT scanners in particular, very, very good at scanning through metal objects, looking for any kind of structural deformities or weaknesses, etc., in the rocket, are going to become more and more important. But I think this is the way forward, especially with smaller launch vehicles. You're not going to build an Artemis right now from a 3D printed technology. You're not going to build anything on that kind of scale, or Starship, but the ability to not only 3D print small satellites in terms of, most of the major structural components anyway, obviously not the ICs, but being able to 3D print most of the structure of a smaller launch vehicle. And we're talking, again, something along the size of Peter Beck, his rocket labs and the ABSL rockets that are planned with Lockheed Martin out of Scotland. That kind of 3D printed technology is going to give a higher kind of turn through of rockets, where you would hope that once they're stable, I mean, this again, you look at SpaceX and you look at their production throughput, it's absolutely phenomenal in terms of the non-reusable parts. They've got a very, almost like an automobile production line going on for the non-reusable parts, but obviously the main structures are reusable. For companies that are trying to, do something on a similar kind of cost model, this is going to be really important. And Chris has just put in the chat, yes, max Q, this is the thing. So maximum dynamic pressure, as it were. When a rocket takes off, there is a point in the launch to orbit where, the atmospheric pressure, etc., causes the maximum amount of dynamic pressure on the rocket surface. Once it's got through that, it nominally then is going to be a safer path to orbit. Obviously, Virgin Orbit proved that, until you're in orbit, all bets are off, as it were, and it's happened with many, many launch vehicles. So this did pass the maximum dynamic pressure. So whether or not that maximum dynamic pressure imposed some structural, or kind of made any structural weaknesses a bit more apparent, or kind of started the process, and obviously you've got all sorts of cooling issues. You're dealing with vast temperatures from the exhaust end of the rocket, plus, the cryo cooling of the propellant, etc. And then obviously you're going up a ridiculous rate into the upper atmosphere, the stratosphere, etc. So, and again, Chris is saying most companies do print multiple engine parts. As I said, I saw this at Skyrora. This is going back 4 or 5 years now. It's the first time I'd seen this on a larger scale. And AAC's Clyde Space. There's various companies just in the UK doing this. So it is a really kind of important part of what's happening. But as you said, Relativity Space, and thanks to Terry and thanks to Chris as well for mentioning that, the engine failed. So a component of it failed in orbit, and as I said, it broke up on its launch. Apologies if I wasn't completely aware of everything on this story. As I said, it wasn't, I believe, but that's all. We've had all sorts of issues the last week or so, even up until about 20 minutes before we were on air. With in terms of going through the stories and what have you. But yeah, it's going to be a really important part of everything moving forward. I don't know what your thoughts are on this printing technology.
Yeah. Just I thought we always go turnabout. So you did Virgin, I did the High Galactic Redshift Galaxy. So I thought this was back to you on the
yeah,
rocket.
I think the slides have got mixed up in terms of the order, but
not
that's
to
okay.
worry.
That's fine.
Anyway, we all pretend to know a little bit about each other's subjects as well. The thing about this rocket was it was even the engines were 3D printed.
Yep.
And you know, when you think of what a rocket engine has to do in terms of the temperature and the pressure and so on that's in the combustion chamber, that is absolutely amazing. The status that they're at with this particular one was 85% of the whole rocket was 3D printed.
85,
and they're aiming to get up to 95% eventually. Obviously, that's going to be an awful lot cheaper. It's also, again, on the same sort of theme or the same philosophy as Elon Musk. Most of it is to be reusable. So that if that was the case, then you're going to get an awful lot cheaper availability to launch, which again goes back to the earlier story of can Virgin compete with this sort of thing? 3D printing almost all of your rocket, and it's reusable. So, you know, the Virgin are really up against it in this field.
I think they are, because obviously you've got the additional cost of the, it's a 747, it's a decommissioned aircraft, and you've got the, the range safety issues. As I said, lots of issues with the regulatory oversight in the UK. I think from a Scotland launch perspective, looking at Ecoscene, for example, Skyroar are not only pioneering the whole concept, of, these. Well, it's not pioneering, but utilizing the concept of 3D printed rockets, but they're also looking at reusable and biodegradable and more environmentally friendly propellants. And that's not a unique thing either. There's other companies around the world that are doing this, but I think that's going to play more and more into not only the cost model, but also the public perception of space flight. Space at the moment, if you mention it to most people in the street, they still see it as a rich person's playground. They still see it as people like Elon Musk, etc., just playing Space Invaders and Star Wars, etc. But it is very important to the economy. It's very important to the defense of the UK and NATO allies, etc. It's very important in terms of Earth observation. So the lower the cost, the better. The overall, and hopefully the increased cadence, because if you can 3D print all of these parts and guarantee that every single one of them, unlike with, say, a human assembled production line where you've got all sorts of potential issues with welding and riveting, etc., and that goes back however many decades, to rockets breaking apart, etc., and it's still happening to this day. I think this is going to be a real game changer. So, and Chris has said, the thing is, with most companies now printing multiple engine parts, as Terry said, the engine, that's probably the most difficult part to cope with, the nozzle, as it were, handling the exhaust gases when you're basically mixing two fuels and they're going into spontaneous combustion. I was looking at some videos from some of the early Apollo tests, and testing that back in the mid 1960s was next to impossible. It was really, really tricky to do in terms of how do you test something where the temperatures and the amount of thermal stress on that and the vibrational stress on that, and then the fact that some of these rocket engines have got a gimbal as well to stabilize the launch. It's really, really hard. So the more the merrier, definitely. So
a pub fact, going back to the Saturn V, the engines, the fuel pumps on the Saturn V engine, which had to pump the fuel into the combustion chamber against the pressure of the combustion going on there, those fuel pumps were more powerful than the main engines on the QE2 liner.
Yeah.
So that shows you what you're up against in actually making a rocket engine work.
And delivering, I believe it was about 15 tons it was
per second.
Per second.
Yeah.
The Saturn V on launch for the first, I think it was 46 seconds for launch, generates more energy than the United Kingdom in terms of gigawatt energy.
Yeah.
It's astonishing. I mean, so when Starship goes live with its massive engine cluster, which is very reminiscent of the old Russian N1 rocket, that's going to be a sight to behold. And I think Musk is probably going to be looking at this and thinking, well, any optimization he can find, and obviously SpaceX are going to be doing 3D printing as well, but any optimizations he can find once this technology has been proven and actually works on a reliable basis. This has been a failure in the first attempt, but I'm sure they're going to try again and try again and try again, and they will eventually succeed. And at that point, once you've got a really high cadence and a really high success rate, this is going to become one of the dominant players in terms of the overall technology for getting us into orbit. So interesting. Moving on to the story that I thought I was doing, but Terry's doing.
Go ahead if you want.
Never mind. No, this is really cool. So this is basically the Dimorphos Didymos twin asteroid system. Now, this was kind of visited by the DART spacecraft recently, and we talked about that in HERA mission, the European Space Agency HERA missions going there. What we found, Terry, is that it's still spinning rocks off the surface. So if you want to take over on that one.
Right, sure. Yeah. This brings us back to another story we covered earlier, the DART mission by NASA. And DART stands for Double Asteroid Redirection Test. And this is the plan by NASA to be able to divert an asteroid if it was on a collision course from on the Earth to change its orbit so it would miss us. And the double asteroid was Didymos, which is the bigger one that you can see there in that picture, and Dimorphos, which is the smaller satellite of Didymos. And the target was Dimorphos because it's small enough for the probe to actually have an effect. And we'd covered this in considerable detail. Very, very successful. And it did actually change the orbit of Dimorphos enough to show that the technique works. If you literally slam something into a body like that hard enough, the kinetic energy and the explosive effect of the material being thrown out from the object by the impact is enough to change the orbit significantly. But obviously, as you can see there, on its way, it flew past the bigger of the pair, Didymos, the parent body, if you like, and it imaged it. And it has been, this whole system has obviously been subject to considerable study since then to see what happened to Didymos, to see just how much the orbit has been changed and so on. How much the orbit of Dimorphos has been changed. But when they studied Didymos, they found that actually it is spinning so quickly. Even though it's a relatively small body, it is throwing rocks and loose material off the equator, which is where the spin effect is obviously greatest. So these bodies, rocks and dust and rubble, stones, pebbles, whatever, at the equator are thrown off into space just by, like twirling a stone on the end of a string around and then letting go. It will head off on a tangent. Now, not all of the material escapes altogether. They reckon that about 95% of it will fall back onto Didymos, partly because the escape velocity is very, very low. And Didymos itself has a very small gravitational field, but nevertheless, there's nothing else there apart possibly from Dimorphos for the stuff to fall onto. Some of it does apparently drift off into space. Small amount of it will hit Dimorphos. Most of it comes back onto Didymos itself and then may be spun off again later. If it lands back more or less on the equator, then there's a better chance that it's going to be spun off again. If it lands at a slightly higher latitude, in other words, more towards the poles, then it's not going to be spinning around so quickly, so it'll probably stay there. But there's an interesting question here, if anybody knows their basic physics. Whenever some of the material is thrown off and does escape, it takes some of the angular momentum with it. Yeah. So in theory, Didymos should slow down as it loses angular momentum. And the fact that it doesn't, and in fact, the reason why it's spinning so quickly, relatively quickly, for every 2 hours, 16 minutes, is because of the Yorp effect. And I'm going to say Yorp from now on because it stands for Yarkovsky-Radievsky-Paddock effect. For some reason, Yorp is much more user-friendly. And that's a very interesting effect. It really only affects small bodies, and basically it's the effect of sunlight. which shining on the body as it rotates slowly, it heats up the material on the side that's facing the sun, and then as the body turns round and that heated material is turned round to the night side, so the energy is radiated off into space, and that gives a spin-up effect. There are other aspects as well, but that's the main one. So the Yorp effect can actually make asteroids spin up so fast that they actually break apart. There's one called P2013 R3, which actually was observed to break apart in 2013 just due to this Yorp effect. So it's an amazing and intriguing vindication of physical theory that this Yorp effect can actually make an asteroid spin up so quickly that it can break apart. And in this case, Didymos isn't breaking apart, but it is casting material off as it spins around. And some of it, as I say, falls back again. The great majority of it falls back on it again. Other bits fall on Didymos, which would explain some of the material that was seen on it whenever the camera zoomed in just before the moment of impact. So a fascinating story, some basic physics confirmed by actual observation out in space. I'm sure your physics is much better than mine, Nick.
Well, it's interesting in that I got involved with a NASA kind of flyby mission about a decade ago now, to a comet called 103P Hartley 2. I don't know if you remember that, very small comet, and very, very active comet. The interesting thing with that, if you look at the images, again, you've got this kind of double lobed Kentucky Fried Chicken drumstick, for want of a better description, and the rotation rate on that at around about 11-12 hours was really high as well. So what was happening with that was that the material, if you look at it, the center of the comet was almost smooth. There was almost nothing there, and the material was almost being dragged towards the poles due to the way it was rotating. What's happening with the Didymos Dimorphos system, as you said, the rotation rate at just over 2 hours, on a 780 meter, wide body, as it were, is causing material to be lifted off, and in some cases ejected completely away. It's achieving escape velocity, some of it dropping back down, but it's then essentially being re-agglomerated towards the polar regions, away from the equatorial region. Now, what you said was correct, obviously, with the Yorp effect. The spin up that's happening is not affecting this rotation rate. But what's interesting about that is the side effects of what could be future asteroid redirect / actual asteroid deflection missions. Because the things we need to consider, the consideration with comets is that, if you remember from Giotto and the Halley mission, in the 1980s, as the Giotto spacecraft approached Halley, the front shield on it was absolutely sandblasted. It was decimated. The cameras were destroyed. They were looking at the impacts on it and visualizing that from some of the broadcasts that we were seeing on television. And it was almost like somebody was firing a shotgun at the front approach plate to it. Now, if you've got an object that is shedding material like this, be it cometary or asteroid in nature, then if you've got an approach spacecraft that is designed to impact and stop it, you've got all sorts of issues with respect to, collision avoidance with debris fields around it. Because what they've noted post the Didymos Dimorphos impact is not only that Didymos is shedding material from its equator, but the Dimorphos impact has left a massive debris cloud around the smaller asteroid as well. So if you've got an approach spacecraft where essentially you could be doing mapping in the first instance before you slam into it, and don't forget the slamming into Dimorphos, that's only 160 meters wide. And we recently, in the last few days, we had what they call a city killer asteroid fly relatively close to the Earth. It was all over the news. They're talking about it. City killers, you're looking at 50 meters kind of plus. What caused the crater in Arizona was a 50 meter wide iron asteroid 60,000 years ago. If we are to look at real impact collision things, the Yorp's effect was one of the things that was considered, and the idea of sending a spacecraft out to an asteroid that potentially could hit us in maybe 2 or 3 decades and paintballing it. That was one of the genuine considerations. And the reason they were looking at that was if you had a load of white paint, for example, and how you do that on a dusty asteroid, who knows? But it was a seriously discussed idea to basically paintball an asteroid and increase its rotation rate due to this Yorp's effect. Now, with a smaller body, if you were to increase the spin, you change the orbit, etc. Yeah, potentially, if you had a number of decades and you could map the object and it wasn't a big rubble pile covered in dust and you could paintball it, because that's the thing. That idea now, I think, is null and void, because if you've got asteroids that are rotating at such a rate that they're lifting dust off the surface, much like a comet does, but then it's resettling, then any of your potential gains from this Yorp's effect with the paintball approach are going to be nulled. So it'd be interesting to see, once the Hera spacecraft goes into orbit around the system, what is actually happening, because the amount of dust and debris that was shed by the DART impact, plus what's happening on Didymos itself, I think that's a major set of studies that needs to go forward. Forget the impact. The impact, as you said, it changed the orbit by about 33 minutes. So this wasn't an insignificant impact. And the idea of using impactors, kinetic impactors, is one of the only ones that we would have in terms of a rescue mission, were something to be coming towards the Earth. The idea of sending nukes, it's not going to happen. We don't have, there wouldn't be any treaties in place. It doesn't matter, who says what, the Minuteman, etc. You've got a very limited range. We don't have that launch capability. We don't have the ability. If Musk causes a debris storm that potentially could happen in Leo, we won't have any launch capability at all. But if we are to look at ways to stop an asteroid or a comet in the future, then a kinetic impactor is potentially one of the ones, depending on how long we've got. If it's a comet, it could be anywhere between 9 to 12 months, depending on where it's found in the orbit. If it's an asteroid, hopefully we've spotted it, with enough time to give us a chance to do something more significant. The other option is to use Starship, and I've been saying this for a long time now. If you had the ability to put Starships in orbits, stable orbits at different points in the solar system with enough fuel, with a refuel mission to them, where you've got the ability to light them up, as it were, and then use them as either impactors or tugboats from an object. But again, it all comes down to whether or not you can latch onto the object, and whether or not the debris around it, if it's a comet, it's going to have a significant coma. It's going to have significant amounts of stuff coming off it. Armageddon, awful movie as it was, did demonstrate that quite nicely. So it's going to be really interesting to watch this moving forward, and hopefully European Space Agency's part to play in this is going to be as significant, if not more significant, than NASA's with the DART mission.
2027 here, I'll be there and have a look. I see a question there from Chris. Does the Yorp effect turn it into a hot fuzz? Not quite. I think hot would be a relative term. This is out in the asteroid belt, well beyond the orbit of Mars. The solar radiation is basically just slightly heating up one side of it above the background temperature of empty space. So I don't know what you mean by fuzz. I don't think it causes any evaporation or anything the way or sublimation as you would get in the case of a comet, but certainly not hot, just slightly less cold, I think is the way to put it.
Yeah, and the thing is, it's the amount. I mean, you imagine you've got 760 meter or 780 meter wide object in, Didymos itself, Dimorphos, a lot smaller. Could you imagine how much you'd have to launch in terms of paint, as it were, to even get close to having a significant impact or effect on that? It's going to be, given the cost of launch. Well, again, this all goes back to what we were talking about before, the cost of launch to orbit. With Starship, it's going to plummet again. Another interesting point that Chris made, printing, 3D printing is quite slow and costly, but he's put a very good point in there, the chat. Fewer parts, it makes it more accurate and reliable. And I know from the work that we do at my company with 3D printing with the maritime domain, yes, that is absolutely the truth. So again, thank you so much to all the people who is coming in on the chat there. Movie reference, ground-based.
Sorry, you've got me on that one. I don't know that one.
Ground-based space talking about movie references. It's interesting on movie references. Armageddon. If you've not seen it, don't. It's awful. Moving on to our final segment for the evening, which is our look up segment, and we've got a lot to talk about. So we've got a new comet coming next year, and I won't we'll probably cover this in a lot more detail over the coming months. But after the last wonder comet that turned into a damp squib, as it were. I mean, I was observing that with a 10-inch f/15 refractor, and it was still just a very small grey fuzzy blob. It was nothing spectacular compared to Neowise at the start of lockdown. But we have got potentially a more interesting comet coming next year. We'll be covering that a lot more over the coming months. But as I said, with comets, this is what, going back to what we were just talking about, comets, the Oort cloud at 1 light year away, which is the kind of reservoir for the long period comets, and then you've got the Kuiper belt, the Edgeworth Kuiper belt, which is the kind of reservoir for the shorter period comets. Long period comets coming from the Oort cloud, we're looking at anywhere up to 1 million years for them to get the 1 light year from where they are, and they're traveling at around about the speed of a 747 into the inner solar system. So they're traveling at a few hundred miles an hour, basically out in the Oort cloud, minding their own business. However, there are a current estimate of 1 trillion of them out there. So new comets are happening all the time, and it's only a matter of time before one of them's got a name on it. But essentially, this new comet is coming in, and we're going to be able to see it. New comets are being picked up all the time, especially with instruments like the James Webb. Hopefully, we're going to have a bit more of an advanced warning, because the James Webb infrared sensors, even though the comets themselves, until they cross the ice line, typically between the orbits of Saturn and Jupiter, and they start to light up and start sublimating and forming comas and tails, is when we generally see them, because the kind of albedo, the reflectivity of a comet, is about 25% that of coal. So these aren't bright objects before they start to light up. So we've got that to look forward to. The big one, however, that most of hopefully the people watching and listening will have seen, is the aurora. We have had, even in the UK, in the south of the UK, even down as far south, I believe, as southern Spain, kind of the Midwest of the United States, some absolutely spectacular auroral displays. The reason for this is that the sun is now come out of its really long, very quiet quiescent period, and we're getting some enormous solar events. We're getting large X-class flares. We're getting huge coronal mass ejections coming off the sun. Interesting thing with that is, yes, it's giving us, if you're up in high latitudes, northern Scotland, I'm going up to Kielder, as I said, this weekend. I'm hoping to see some of this if the sun gets active again. Obviously, look out to various websites that give you a raw kind of heads up, as it were. It was spectacular. I could even see it from the back garden, a kind of dull pink glow with averted vision. With a camera with that 5-second exposure, I've seen some amazing images, showing the striation, showing real depth of color. Up in the high northerly latitudes, up to Svalbard, Sweden, Norway, etc., it was the sky was on fire, as it were. Some really, really spectacular displays. What this, however, means is that the sun is getting more active. And the problem that we've got with that goes back to our talk about satellites, etc., before, because the last time the sun was giving us this level of activity was probably in the late 80s. And some of the coronal mass ejections and the large X-class flares that were coming off the sun then were sufficiently powerful enough to knock out the entire power grid, or most of the power grid, in Canada, and set fire to power stations in doing so. Now, compared to the late 80s, where we had largely government, defense, military satellites in orbit, we've now got thousands and thousands, and Musk is responsible for over half of them, of commercial satellites, which really don't have the levels of resilience that may be needed if we were to get a huge solar event on a like Carrington scale event. If you remember the Carrington event in the mid 1800s, which just lit up the telegraph lines across the entire Midwest. So that's one to watch out for. But in terms of beauty, if it happens again, and keep an eye out for, there's various websites and Twitter feeds that'll tell you about potential auroral displays. Absolutely worth seeing. If you've not seen an aurora in all of its glory, it's one of those things like an eclipse. And I know you're off next month to see the eclipse in Australia, Terry. It's one of those things, isn't it, that you just have to see.
Absolutely, yeah. The sky can be on fire, literally. Blazing colours dancing around. The Scots call them the merry dancers, which I think is a nice term, because these lights can often have vertical components, rays straight up, and they flicker around the sky and move around. So I like that. But the interesting thing about this recent aurora was that it wasn't caused by what we call a coronal mass ejection or associated with any sunspots. It's what we call a coronal hole. Yep. And you can actually see these in the images in H-alpha light, where basically it's not a hole as such, but it's an opening, a major opening, if you like, in the sun's magnetic field, which lets all these particles out. And even more interestingly, about 3 weeks ago, maybe 4 weeks ago, there was an even bigger one on the far side of the sun, which they reckon was probably as big as the Carrington event. Fortunately for us,
going the other way,
in the opposite direction. But if that had been coming this way, we might not be online here talking tonight. The systems could still be down.
Yeah,
that's seriously how big it was.
It's a significant thing that's been discussed even up to government level in the UK as a major threat, potentially space weather. And there's some serious discussions going on about this even to this day, with the future ideas for where defense is heading, etc. This is one of the significant problems. You've got collision avoidance, but collision avoidance can be caused by the fact that satellites, which are formerly quite happily working and active, and they've got thrusters and reaction wheels, and they're moving between their orbits, and they're quite happily doing their merry thing, suddenly getting knocked out. If you knock out thousands of them at once and they're completely uncontrollable, that's not a good thing. So yeah, right. X-class events, fissures, rips, as it were, in the sun. All of this is bad news, apart from if you like looking at pretty displays and taking really nice pictures.
I love the sense of humor there. Sorry to interrupt my homework. Watch more Simon Pegg movies.
Well, so Hot
Fuzz, by the way, just for the record, it's YORP, YORP. YORP, not ARP. Okay, back to you, Nick.
No, Simon Pegg movies, definitely. Hot Fuzz is a great film if you've not seen it. Right. It's kind of from Shaun of the Dead kind of era. Simon Pegg and his erstwhile colleague. Planetary alignment, yes. Only yesterday we had a phenomenal planetary alignment where you had 5 planets plus the moon all in a beautiful arc that if you had a really low kind of horizon towards sunset, you could see all at once. So it's we're entering galaxy season now, and everyone, if you've got a telescope, will be pointing towards, some of the big kind of galaxy clusters, as it were. There's still some fantastic planetary observations, especially Venus. The phase on Venus is changing all the time. It's well worth seeing, and if you've got even a modest telescope, being able to see Venus, Jupiter, Uranus. Even if you've got a modest telescope, you don't need to have a massive telescope to see Uranus. If larger the telescope, you'll see that it's not a star, that it's got defined color in it, and that there is a disk. But absolutely 100% worth seeing. Venus, Orion, and the Pleiades. Orion's starting to dip now, the Pleiades as well, but Venus is still a spectacular object in the kind of sunset time as well. Always be careful. That's another thing we always have to say. If you've got a low horizon, wait until the sun has gone below the horizon before you start using any optical aid, telescopes, binoculars, for anything, especially if you're looking for planets which are really close to the horizon. When will we lose this cloud, says Rob. Who's buying the telescopes, Robert, is all I've got to say on that one. There's a thing with astronomy that if somebody buys a new telescope, it's cloudy. It's cloudy for weeks. Hopefully we've got another week of this, and then maybe it's going to get better. It's been pretty rubbish the last few weeks. We had a really good January for some bizarre reason, but it was so cold then. But I don't know what your thoughts on Terry. You do so much observing as well.
Same sort of thing. Just that planetary alignment, I think, was a little bit overhyped because you had to look at just the right time to get Mercury and Jupiter very low down in the twilight. But if you knew that was happening and you're in the right place at the right time with a clear sky down to the west, then you could see them all. But Venus, as you were mentioning, it's going to be the highlight of the sky for the next couple of months, getting higher up and brighter all the time, hundreds of times brighter than any other star-like object in the sky, outshone in the night sky only by the moon. So when it's like that, it's called the evening star, and it really is just an absolutely beautiful sight. You can look out for it on the 23rd of April, when it will be just below a nice crescent moon, and that will give you a lovely photographic opportunity. And Mercury, we mentioned there, at the time of this alignment right now, Mercury is very low, but it is actually moving out from the sun. And quite a few people, even those interested in astronomy, have never actually seen Mercury because it's always close to the sun in the sky, and therefore it's always low down in twilight. And if you've got high trees or hedges or buildings around, you may find it quite difficult to see. But it's coming at its best appearance for the evening sky for this year in the next couple of days, up until I think about the middle of the month. In about a week from now, it'll be relatively easy to find just 20 degrees below and right of Venus, and Venus is unmistakable. 20 degrees is a bit less than the length of the constellation of the Plough, or it's roughly the distance between Betelgeuse and Rigel in Orion. So if you look down at 45 degrees from Venus in the twilight, use binoculars if you have them, you should be able to spot Mercury, and it's a good chance to see it.
Absolutely, and a good rule of thumb in terms of size as well. If you hold out your arm and the distance between your thumb and that finger is around about 15 degrees, typically. So, 20, 25 degrees, it should be quite easy to pick up. The thing as well, if you have got a good high-powered telescope looking at Mercury, you'll see phasing on this. This is one of the really fascinating things. And as Venus climbs, obviously the phase is changing. It's getting further away from the sun, and the relative angle between the Earth and the sun and Venus itself is changing and giving you this phasing effect. As Terry said, it is the brightest thing in the sky. If you can get out to a really, and I mean really dark sky site, somewhere like mid Wales, Northumberland, northern Scotland, etc., Venus has been known to cast shadows. It's so bright. Now, to see that, I mean, I've been very fortunate. I've been in Tanzania and seen that, and even we believe that Jupiter was casting shadows, but that's hit and miss, as it were. It's got to be phenomenally bright for an opposition, but definitely Venus. I've seen Venus casting shadows. You put a twig in the ground and you can see it really clearly. So especially when obviously there's no moon about and you're not getting any additional light pollution. So definitely. Chris is saying a beautiful Sunday here in Cheshire. Absolutely. I was out in Marlborough College about a week and a half ago, observing through this enormous Cook refractor. It's 10-inch f/15 refractor that they've got at Marlborough College, which is not too far from me. The seeing that night was sub-arc second. It was some of the finest seeing I've ever been fortunate enough to have access to a big telescope at the same time as. We were looking at the lunar surface, really nice moon phase. Lunar craters only a few hundred meters wide. I mean, really clear. We identified Armstrong, Aldrin, Collins craters, for example, on that night, and some of the craters surrounding them. We were looking at the lunar maps. They are very, very small. So if you do get a really good night with what's happening with the jet stream and the weather at the moment, it's worth getting out with a telescope. On that note, we'll be back. Well, I say we will be back next month.
My apologies in advance. I'll be away in Australia for a total eclipse.
So there'll be a slightly different show. We're still trying to work out. We might get a guest on for that one. We have no presenter kind of from Space Tour tonight, unfortunately, because Latch, our normal presenter, and Get Well Soon, Latch has got a bit of the lurgy. So again, thank you to all the team at Space Store. Please visit the Space Store. Give them your support. If you're anywhere near Oxford in the covered market area, they do wonderful stuff, fantastic experiences, lots of VR work. You can dress up as an astronaut if you take your kids. They've got a big space camp event coming up in the next few weeks as well. So have a look on their website for all the details of the events that they're dealing with. Thank you so much to everyone in the chat. Apologies for the slightly skewed show tonight. We had a few, like I said, Terry and I were panicking about 5 minutes before we're due on air, like there were all sorts of little technical things in the background. But again, massive thank you to all of the Space Tour team for helping us put this together every month. We'll see you. I'll see you in a month. Terry, have an absolute blast in Australia. One of my favorite countries in the world. I am. Jealousy is the wrong word, but I love Australia. It's an amazing place. If you're not,
I'll send you an e-card.
Brilliant.
Okay. Cheers, everybody.
Safe
and
travels,
good luck for whoever's in this seat in 4 weeks' time.
Brilliant. Thanks very much,
everybody.
Take care. Cheers. Bye. Bye.